Welcome to the third presentation in Unit 5 on circuits. It says a series of obstacles. It says the only use of an obstacle is to be overcome. All that an obstacle does with brave men is not to frighten them, but to challenge them. Woodrow Wilson. So the goals for this particular presentation is that you be able to identify a circuit as being wired in series, understand the role of a fuse or a circuit breaker, and predict the resistance of a series circuit. So here's what we know. We know that a circuit requires a closed path in order to function, something that is not here. This is considered to be an open circuit. It needs a voltage source, generally speaking some sort of resistor or something to use the energy from the circuit, and some sort of connecting wire. Now in order for this circuit to function, I would actually have to close the switch and actually make the circuit function that way. Now what we learned in the lab is that adding resistors in series actually made the light bulb dimmer. Whenever you make the light bulb dimmer, there is less power or less energy being emitted by that particular resistor. Now, whenever you wire something in series, a series combination is one in which the charge must flow through those connections. So in other words, if I flow through this particular resistor, I have no choice but to flow through this resistor as well. In other words, I have to flow through this one and this resistor. So these two resistors right here. As a result, these two are in series. But if you look, there's a third resistor here that is also wired in series, because I must also go through this third resistor in order to get to the other end of the battery. Since these three resistors, I have to go through all of them. All three of them are said to be wired in series because there is no alternative pathway. I have to go through them all. Series is like a one-lane road. If you have some sort of stop or some sort of accident right there, since it's a one-lane road, everybody else is stuck behind you. So because of that, if there's some sort of break in a series circuit, so for example, if I have a resistor, a resistor, a resistor, and then you've got your battery right here, if there's some sort of break anywhere in the circuit, none of the other resistors will get any sort of charge because there's nowhere for the charge to go. So series circuits are really useful because that's actually how fuses and circuit breakers are wired. You actually have this right here, which is a circuit breaker from a garage, and in that circuit breaker you have a little switch. And if you flip that switch, all of the electricity to that particular circuit is shut off. And that's really useful because if you didn't do that, if you flipped that switch and there was still some sort of charge going to the outlet, it'd be really difficult to work with things like outlets and switches and changing out light bulbs and those sorts of things. So it's really useful to actually have fuses and circuit breakers wired in series. In addition to that, you can actually use series circuits to manipulate voltage. That's particularly useful when we talk about video game controllers. Now, whenever you have resistors wired in series, they have to have a complete path. They have a single path, a single complete path to reach the opposite terminal. There's only one way for me to go through these particular resistors. Now, if we look, how are these particular resistors connected? It's really difficult whenever you're actually working with this on a circuit board because it's all kinds of confusing. You have to start with, okay, here's my positive terminal. I know it's my positive terminal because it's red coming off the variable voltage supply. So as I kind of go here, I get to this value, I get to this resistor here. I have no choice but to go through this resistor. Then I have no choice but to go through this resistor. Then I have no choice but to go through this resistor. Then I have no choice but to go through this switch. Then at this point, do you see how there's two different branches that I can go right here? One of them goes this way. It looks like it goes behind this particular object to the other end of the battery. The other one looks like it goes this way to this particular terminal right here, and then this other terminal comes right here. So if you look, I have no choice but to go through this resistor, this resistor, this resistor, all at the same time. So because of that, we say that those are wired in series. Next it says, draw a circuit schematic for 3 resistors wired in series connected by a voltage source. There's my voltage source, resistor number 1, resistor number 2, resistor number 3. All of those are wired in series. That is a series circuit. Identify any resistors that are wired in series. This is a little bit trickier one because you have your positive terminal here and you have your negative terminal here, and you have to look through it this way. If I go through this particular light bulb, which is a resistor, I can now have a choice. I can go this way, I can go this way, or I can go this way. So these three things, these three resistors, none of them are in series. But now you have to look at this original light bulb. It's interesting because if I go through this light bulb, I have to go through one of these particular resistors. But I only have to go through one of them, but I don't know which one. So you can think of these as two ways. You can think of this light bulb as being in series with all of them, because if I go through this light bulb, I have to go through one of these other resistors. And that's the best way to think of this. So these three are not in series, but this one light bulb is in series with each one of these. A fuse or a circuit breaker, we've already talked about a little bit. We showed your circuit breaker. We've talked about this fuse. The reason why you generally would like to use a circuit breaker instead of a fuse is circuit breakers are cheap. And the reason why they're cheap is because they can be reset. This is what you have in your garage, is you can actually just take it and go and flip the switch and it'll work. Or you can flip it the other way and it will work. If you have fuses instead, which you won't have a fuse box unless your house is pretty old, you have to put these little cylinders that are, you have to put these little cylinders in there, and once it melts, it's done. And it has to be replaced. And because it has to replace, it's expensive. Circuit breakers are reusable because they bend when heated. Now, at the same time, you will see fuses in certain things. The variable voltage supply actually has two fuses that are in it. So whenever you control the voltage right here on the back, there's going to be a fuse. If the current gets too high as it's going through this particular thing, that fuse will melt. So fuses are nice whenever you have a low likelihood that you can access this particular part. So for example, there are a lot of fuses in cars because it's not likely that you're going to have to get in there and reset the switch. Now, a properly wired fuse melt, what happens to the rest of the devices in this instant? So you have some sort of voltage source, and whenever you have a voltage source, you always have to wire that fuse in series with whatever you have next. I have no idea what's next. Okay? If the fuse is wired in series and it melts, it doesn't matter what's after that particular fuse, nothing will receive any electrical current. A series circuit is one in which you have only one, the charge has only one choice to move down a path. In other words, it has to go down this path, and then it has to go down this path. This voltmeter is not wired in series with the resistor. Instead of going through this particular resistor, I could go around it and go this way. So the voltmeter is said to be wired in parallel, and we'll talk more about that in the next presentation. But because it has an alternative or a second pathway, it is not considered to be in series. These two resistors are considered to be in series, because if I go through the first resistor, R1, I have to go through the second resistor, R2. The second part of that is if you remove any particular component of a series circuit, it will disconnect the entire thing. Now, when you do this, this will actually cause all of the lights to go out, and that makes it really frustrating if Christmas lights were in series, and because of that, they're not in series. And the reason for that is if you had Christmas lights and there's all kinds of them, there's 100 of them on the string, if one of those things went out, they would all go out. Well, if they all go out, how are you going to figure out which bulb it is? So you'd have to test every single one. Because of that, you have bunches of wires that are used for these bulbs, and they're actually connected in parallel. Whenever you talk about the current in series, the current stays the same. Now remember, current is the amount of charge. It's actually the charge per time. Well, if I'm in series, let's kind of ignore this voltage part for now. Let's say that I have one charge as it goes through the circuit. Well, if I have one charge that goes through this particular resistor, that one charge eventually has to go through this resistor. So because the charge has to go through both of these, and charge is always conserved, whatever you have in the first resistor as far as current is what you have in the second one. So the current remains the same everywhere in a series circuit. So if the current here is 2, well, over here it's 2, 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 because charge is always conserved. Now when you look at the voltage, it's a little bit different. Okay, the voltage is the energy that's provided to the circuit. Now we've already said that what resistors do is they actually use some of that energy. So what happens is I go through the first resistor, I use some of the 1.5 volts, so there's less after I go through the resistor. And then there's less after I go through the second resistor. And the key to these problems is by the time I get to the other end of the battery, I'm at 0 volts. So if I start at 1.5 volts on the positive side, all of that 1.5 volts has to go somewhere. You can calculate those using Ohm's law. If I were to look at the voltage drop, otherwise how much energy is used by that resistor, all I would need to do is say current times the resistance. Now, resistors are particularly useful in series whenever you're talking about a joystick. What joysticks do is they actually detect small changes in the current as you slide a resistor into place in the circuit. The reason why this is particularly useful is whenever you have something like a button on a computer, the button actually works with something called a capacitor, and it requires you to physically move the capacitor closer to the other end and allow a discharge to occur. Well, that's really good and everything, but what happens is there's a certain amount of time that it takes in order for the capacitor to charge and discharge. That's a reason why no matter how fast you push a particular button, these buttons can only be pushed so fast because the capacitor has to charge and discharge. Well, that's all well and good for a button where you're trying to jump or fire or something like that, but whenever you're looking for smooth continuous motion like with the joystick, you want to have a smooth motion. So what happens is you slide a resistor into place. Whenever you slide a resistor into place, the current will actually change. The computer can detect the lower current, and because of that, will actually continuously move the character in that direction. Or whenever you slide a different resistor into place, it detects that current, and what it'll do is it'll move the character in that direction. Now, series circuits in action. They're useful for fuses, they're useful to manipulate voltage. We've already talked about that quite a bit. The resistance of any one resistor, the resistance of the circuit is greater than any one resistor. If this is 10, and this is 10, and this is 10, by going through all the 10 resistors, the total has to be greater than the individual pieces. Now, the blank drops as resistors are added in series. Now we've talked about current and we talked about voltage. Now current, we said, is the same as you go through the circuit because of the law of conservation of charge. If I have 2 amps of current, that 2 amps of current has to go through the entire circuit no matter where I am. But the voltage has to end up at 0. So if I have 1.5 volts to begin, I have to end at 0. So the voltage drops as you move through a circuit. Next we have what happens to the current as resistors are added. The current we just talked about stays the same as you go through the circuit.